For today's double, we are going to look at transforming parabolas. We already covered most of this in yesterday's class when we looked at graphs that were moved, flipped, or made wide or narrow. I will show you how the equation of a graph makes these transformations. A dilation is when we change the value of the number out the front of x squared. This is what I have called a. So if a is a number larger than 1, for instance 3 or 7 or 100, then the graph is made narrower. So it'll look something like this. But if a is a number smaller than 1, so say a fraction or something, then it is made wider. So it'll look like this. A reflection is when there's a negative sign out the front. We saw yesterday that this means that the graph is flipped upside down, so it looks like this. Translations move the graph. When the brackets have a negative number, we move right, which is kind of the opposite to what you would think. And when there's a positive number in the brackets, we move left. The other type of translation is moving the graph up or down. When the number at the end is positive, the graph goes up. This makes more logical sense. And when the number at the end is negative, the graph moves down. So if it is all put into one equation, if there's a negative out the front, you flip. The value of A makes the graph narrow or wide. The number in the brackets moves the graph right or left. And the number at the end moves the graph up or down. Let's have a go at roughly sketching some transformations. This equation has a number out the front of x squared, making it a dilation. Because the number is larger than 1, the graph is going to be made narrower than the basic parabola. So it looks something like this. There. Let's have a look at the transformations of this equation. So there's a negative out the front, which is a reflection. So this means that the graph is going to be flipped upside down. There's also a number at the end of the equation. So this is a translation. And because it's a positive number at the end, this means we're going to be going up 4 to be precise. So over to my graph, I'm going to go up 4, 1, 2, 3, 4 to here, and then flip the graph upside down like this. This last equation has a number in the brackets, which is a translation. This type of translation is going to move the graph right 2. So I always move from the turning point, it's easiest, and then go across 1, 2, and then in a smooth motion draw in the parabola. There we go. These are the textbook questions I would like you to do. For question 2 and 4, just do a rough sketch like I did with the examples. Don't worry about labeling the intercepts or anything, though you could have a go at the turning point if you like. Then for question 5, you just need to write the equation based off the transformation listed.